Hello and welcome. This is going to be our homework help video for the homework operations with imaginary numbers. Let's get started with some multiplication like in number 1. To multiply two imaginary numbers, you need to FOIL, essentially. You multiply the real part to the real part, then the first real part to the second imaginary part, the second imaginary part to the first number's imaginary part to the second number's real part, and then the imaginary parts, we multiply them together. And after we do this, we would get negative 8 times 3. Well, that's negative 24. Outside, that's going to be a plus 32i. Inside, that's going to be a plus 12i. And last, 4i times negative 4i, that's going to be a negative 16. The 4 times 4 becomes a negative 16. And the i's multiplied to become an I squared. Now here we need to know something about I squared. Because I is equal to the square root of negative 1, I squared is equal to negative 1. Square both sides, you get negative 1. So negative 16i is the same as negative 16 times negative 1. This is the same as plus 16. So this is the same as a plus 16. All right, so I can combine that plus 16 and that 24, that negative 24, to get a negative 8. And then the imaginary parts combine to get me a plus 44, back arrow, plus 44i. All right, so that's how we multiply. When we expand here, number 3, very similar, but we're just going to write out 2 copies of this complex number. 1 minus 7i times 1 minus 7i, and then just FOIL those. First to first, 1, first to second, minus 7i, second to first, another minus 7i, and then last to last. The negative 7 times negative 7 becomes a plus 49. I squared, that's going to become a minus 49. Combine your like terms, or combine the real parts and combine the imaginary parts, we get a minus 48, minus 14i. All right, we got to simplify these fractions. Well, they already look pretty simple, but what we want is the simplest denominator possible. When it's just a single, just an imaginary number without a real part on the bottom, we can multiply by I over I to make the bottom no longer imaginary. We don't want an imaginary denominator. The top here would be negative 6i, the bottom would be negative 10i squared. That's going to become a positive 10, so we get negative 6i over positive 10. We can simplify this further by dividing the top and the bottom by 2. And we get negative 3i over 5. Yeah, as long as whatever you do to the top, you do to the bottom, you'll always get an equivalent fraction. Let's see, here we got a mix of operations. Let's pick one, like maybe one of these last two that look a little bit longer. I guess 17 looks maybe kind of tricky. But we just take it one piece at a time. I'm going to FOIL these first two imaginary numbers. Look at minus 28, minus 12i, plus 56i, plus 24i squared. Here I'm going to drop some parentheses, minus 1, minus 8i, minus 6, plus 4i. Let's combine all of our like terms. That was right here, that's a 24i squared, so that's going to become a minus 24. Let's get all the real parts together, the negative 28, the negative 24, the negative 1, and the negative 6. We need some calculator help on that one. Negative 28, minus 24, minus 1, minus 6. All of those combine to be a negative 59. And now let's combine all the imaginary parts. Negative 12i, the 56i, this negative 8i, and this 4i. So negative 12 plus 56 minus 8 plus 4 is a positive 40i. And I could have easily made a mistake there, so let's just check 17. Negative 59 plus 40i. All right, on to the next page. Now we've got some fractions that have got this binomial imaginary number, or an imaginary number with both a real and an imaginary part. The only way to get rid of this is to multiply, or the only way to make this real is to multiply it by its complex conjugate. To create a complex conjugate, you just take that middle operator and you flip its sign. So 7 plus 4i is going to become 7 minus 4i. And then I need to turn this into a form of 1 by putting that same thing on the top. Parentheses are our friend here to help make sure we do this correctly. So this is still a form of 1. I'll write that here, form of 1. So it doesn't change our fraction to multiply by this, but it will make that denominator real. All right, first to first, first to second, second to first, second to second, FOIL the top and the bottom, and what do we get? We will get a 42 minus 24i minus 7i plus 4i squared. Negative I times the negative 4i is going to be a positive 4i squared. But that there is going to become a minus 4. And then this is going to be on the bottom, we got a 49 minus 28i minus 28i minus 16i squared. That'll become a plus 16. Combine the real and the imaginary parts on the bottom and the top. Let's see what we get. The negative 4 and the 42, that's going to become 38 minus 24i. The 49 and the 16 is going to become a 65. Negative 28 minus 28, negative 56. I. Now we look and see if maybe there's a common factor here. Nothing's jumping out at me. Let's just see what 19 is supposed to look like. Oh yeah, I made a mistake here. So when we do the outside, we'll get a minus 28i. When we do the inside, we'll get a plus 28i. So these cancel out. I wasn't even thinking, because the whole point of this was we wanted to make the denominator rational. It's supposed to be just a 65 on the bottom. Now I think that matches pretty well. 38 minus 31i minus 31i. Oh yeah, negative 24 minus 7. Oh, I had a rough time on this one. So that's why you double check your work though. All right, and yeah, there's no common factor between 38, 31, and 65, so we'll just leave our answer like that, just as we saw in the answer choices. I think, all right, hopefully we're good on that. Sorry I botched it a little bit, but yeah. Complex conjugate, make it into a form of 1, FOIL the top and the bottom. All of the i's should cancel on the bottom, unless you're not paying attention, like I just was. All right, factoring, we're going to use factoring by grouping. So for all of these, factoring by grouping is just going to work, but it's always a good idea if you have 4 terms to try this, because it's a really quick method when it does work. So what we do is we just group together the first 2 and the last 2 terms, and we factor out the greatest common factor. Right here it looks like it'd be a 2v squared, leaving behind a 6v plus 7. And then here the greatest common factor looks like it would be a 7, leaving behind a 6v plus 7. And we can see it does work out because we got the same binomial left behind. So we can just rearrange this where the 2 things we factored out come together to make their own factor, the 2v squared and the 7. And then we just keep 1 copy of this 6v plus 7. So for all of these, it is going to work out, the factoring by grouping, but even if it doesn't, it's a pretty quick method, a quick check to avoid doing much longer factoring techniques. Let's just try it with one more, maybe like this one. So add in those arbitrary parentheses, there's a plus in between them still. Factor out to the common factor. Here it looks like it'd be a 3m squared, leaving behind a 7m plus 2. And here the greatest common factor looks like it would be a minus 5, leaving behind a 7m plus 2. So the factoring by grouping worked. We'll just now regroup what we factored out and one copy of what got left behind. And now if we were to solve this, we could set these equal to 0, and both of them would be pretty easy to solve to get us some answers for m, or some roots, or some zeros. All right, find all roots. Well, these are all in factored form, which is really nice. So all we have to do is use the zero product property. I'll just do 35 because it looks good. I'm going to set each of these factors equal to 0. That's the zero product property right there. And now these, each of these can be solved pretty quickly. Add 3 to both sides. 2x equals 3, divided by 2, divided by 2. X equals 3 halves, so there's our first answer. Here, minus 4, we can solve by taking square roots. X squared equals negative 4, take the square root, take the square root. X equals plus or minus 2i. The square root of 4 is 2, so the square root of negative 4 is 2i. And last one, plus 9, 2x squared equals 9, divided by 2, divided by 2. X squared equals 9 halves. Square root. X equals plus or minus the square root of 9 halves. This can be simplified further. We could distribute the square root to the top and the bottom, and then multiply by the square root of 2 over the square root of 2. But for right now, this is a fine answer for the 2 remaining roots for question 35. All right, so there's your homework help video for this one. Have a good rest of your day.